Hello, I hope everyone is doing well today. Today we are going to talk about variation functions. Let's start off by first writing down the definitions of the different variation functions. The first one is direct variation. Direct variation is a relationship between two variables, x and y, that can be written in the form y equals kx, where k is the constant of variation. Joint variation is a relationship between three variables, x, y, and z, that can be written in the form of y equals kxz, where k is the constant of variation. Inverse variation is a relationship between two variables, x and y, that can be written as y equals kx, where k is not equal to 0. And combined variation is a relationship that combines both direct and inverse variation. Please take a moment to pause this video and record these definitions. Now let's take a look at some examples of how to use these variation functions. Y varies inversely with x, and y equals 6 when x equals 5. Find x when y equals 45. The first thing I notice is that y varies inversely with x. That means I know I have the equation y equals k over x. But I know a little bit more. I also know that y is 6 when x is 5, so I can write the equation 6 equals k over 5. I can take my equation and multiply both sides by 5 to get that k is equal to 30. So for this particular function, I can write it generally as y equals 30 over x. To answer the question of find x when y equals 45, I can now plug in 45 for y and solve for x. So I have 45 equals 30 over x. Well, I have a proportion because I can write it as 45 over 1. To solve a proportion, I'm going to cross multiply, and I would get 45x equals 30. And then to solve for x, I would divide both sides of my equation by 45 and get x equals 30 45ths. But 30 45ths can be reduced because they both have a common factor of 5. I can divide out the 5 and get 6 ninths. 6 ninths can be reduced even further to 2/3. So now that I've reduced it completely, I know that x is 2/3 when y is equal to 45. Please take a moment to pause this video and record this example. Now let's get another example. The volume of a rectangular pyramid varies jointly as its length, width, and height. The volume of a rectangular pyramid is 20 centimeters cubed when the length is 6 centimeters, the width is 2 centimeters, and the height is 5 centimeters. Find the width when the volume is 32 cubic centimeters, the length is 3 centimeters, and the height is 8 centimeters. Well, I know that joint variation means that I am multiplying together several variables with a constant k. In this case, I can write the equation v equals k L W H. V for volume, L for length, W for width, and H for height. Now that I have my equation, I'm going to substitute in the known values. 20 equals k times 6 times 2 times 5. I'm going to simplify my equation to get 20 equals 60k. And now I'm going to solve for k by dividing by 60. And I get that k is equal to 20 60ths, or 1/3. So I can now rewrite my equation as v equals 1/3 length, width, height, LWH. Now to answer the question, I'm going to substitute in my known values and solve for the width. So I know now that my volume is equal to 32 centimeters. I'm going to substitute in 1/3 for k. 3 for L, W for the width, and 8 for the height. I'm going to simplify my equation by multiplying together the known values and get 32 equals 8w. I can now solve my equation by dividing both sides by 8 and get that my width is 4 centimeters. Please take a moment to pause this video and record this example. Now I want to take a moment to rewrite some of our equations. If we take our direct variation function y equals kx and we solve for k by dividing both sides of the equation by x, we get k equals y over x, so our constant of variation is a constant ratio. If we take our inverse variation function, y equals k over x, and solve for k by multiplying both sides by x, we get k equals xy, a constant product. We can now use these rewritten equations to identify k from a table and determine whether or not our table represents direct variation or inverse variation. Looking at my first table, if I take x and y and I multiply them, for my first coordinate, 4 times 10, I get 40. If I multiply 12 by 30, I'm not going to get 40, so I can already rule out inverse variation. So now I'm going to try looking to see if I have a constant ratio. So I'm going to take my value of y, 10, and divide by 4. When I divide 10 by 4, I get 2 and 5/10. Now I'm going to go to my next values in my table and take 30 and divide by 12. When I divide 30 by 12, I also get 2 and 5/10. And finally, I'm going to take my last set of values and divide 37 and 5/10 by 15. When I do that division, I also get 2 and 5/10. Therefore, my first table represents direct variation, and the constant of variation is 2 and 5/10. So the equation would be y equals 2 and 5/10 x. Now if I look at my second table, let's start off by multiplying together 5 and 1 6/10. When I multiply 5 by 1 6/10, I get 8. When I multiply my second pair of values, 10 by 8/10, I also get 8. And when I multiply my third set of values, 32 times 25/100ths, I get 8 again. Since I have a constant product, I know that I have inverse variation, and I know that my value for k, my constant of variation, is 8. So I can write my equation as y equals x divided by 8. Please take a moment to copy down these two examples, as well as write down any questions you may have before our next Zoom meeting. Take care.